you. Have a good day.
Yo, Johnny. You took Goo here, right? How's he gonna get back? Catch a ride?
Hey, do you have some coffee for my car?
Huh?
You have some coffee for my car? I can take that.
Sure.
Hey.
Yeah, you better do it while you still have a car.
Whoa, what's that supposed to mean? Am I getting grounded after this test?
I don't know. How'd you do?
Excuse me?
How'd you do on it?
This test? Oh, I don't feel good at all.
Well, you're gonna give him a good grade, or you're not gonna get blown up. Literally not.
We have a new seating chart.
Ethan, you're number 16. Desk 6.
You're one of these two.
Next time. Okay, I need you guys. You will need to get out assignment 40, so go ahead and do that, please. You're in C12.
And the coach were using me.
So it's probably this one or this one. I don't remember.
Hey, they were like, they were like, no, it's not good. They were fine. All this stuff that I know you're not. And they freaked out.
Did y'all talk for a while?
Like 30 minutes later.
Okay. All right, good morning, guys. We are going to look at a little bit of a couple different things this morning. So first thing we're going to look at is one of the handouts you picked up, number 42. So I was unable to get that stapled for you, but we need to talk about this thing called extreme value theorem. So if you remember the first couple of weeks of school, we did something called intermediate value theorem. And within this unit, we do the extreme value theorem and the other one. There's three big theorems in this unit called mean value theorem. So this is really an extension of what we did last class. So we're not going to do all of 42 today. We're just going to start it, talk about it. You'll have more time to finish it at another date, but I want you to be introduced to it. Then if there's a question or two that you needed help with on your homework, I will offer to take those questions, but I will be asking for number 40 to be turned in next class. So if there was any that you struggled with, Henry's, now's not the time, please. And then finally, that short book assignment that I was wanting you to get to last class and we just didn't have time. I will give you some class time to actually do that. And if it's not enough, you'll need to finish that for homework. Okay, so for extreme value theorem, when you hear the words extreme, what does that mean to you?
It's the highest or lowest point of the graph.
Okay. So if your parents say you're being extreme, you say I'm being the highest and lowest point on the graph?
Yeah, I say exactly that.
Okay. Sorry, my computer's been a little slow here for a second. Okay, but yeah, you're on the right track. Extreme means the absolute biggest, absolute smallest. So last class we had talked about relative max and mins. We talked about relative max and mins. Oh my gosh. Sorry, it's opening up all the windows that I told it to open up earlier. And then today we're going to take that and figure out the absolute max and mins. So a relative max is if you're just looking at a small set of data where the maybe if I send it now, it'll be easier. If you're looking at a small set of data, the biggest or smallest point is how you get local or relative mins and maxes. And then extreme value theorem is how we're going to get the absolute biggest and smallest values. So not just in a small set of data, but within the whole thing. Okay. And this is number 42. This works better. Okay, there we go. Sorry about that. I don't know what its issue was. Okay, so if we are interested in absolute max and absolute mins, this is something called extreme value theorem. This is definitely of the three big theorems, mean value theorem, which you haven't learned yet, extreme value theorem, which we're about to talk about today, and intermediate value theorem, this is probably the one that gets asked the least often, but is one of the few things I can promise you will be on your AP exam. This shows up on FRQs quite a bit. So as far as finding the absolute extrema, and then we have this thing called a candidate's test, which is really the way that you're supposed to justify your answer here. Again, it's kind of, you've seen the calculus behind this. It's a matter of just seeing how a couple of things pick up. So let's say that we had some kind of graph that's got a relative max. Let's make sure he has a relative min. And then let's say he goes up to here. Okay, I'm going to label some of these points. So here's where x equals a. This would be a b, c, and d. Okay, so last class we talked about the first derivative test, which can help you find relative max and mins. So the first derivative test could help us find this and this, where the graph switches from increasing to decreasing or decreasing to increasing. But extreme value theorem wants us to consider those points, but also think about the big, absolute biggest and absolute smallest points. So where is the absolute biggest point on this graph? Okay, x equals d is the absolute or global max, and where is the absolute smallest point? Okay, so C is, here's what you need to understand about extreme value theorem. C is a relative min. D is not a relative max. There's two types of numbers you need to consider to know whether it's extreme max or extreme min. When I say extreme, that's also absolute. So the candidates, the things you need to think about, are all of the relative, actually, let's just say critical numbers. Critical numbers are going to give you all of the relative extrema, like x equals b and x equals c, which could be the absolute min. But x equals d, this is not a relative max. So instead, what is it if it's not a relative max? Well, it's the absolute max, but beyond that. Perfect. It's the endpoint. So all the absolute biggest and smallest values either occur at a critical number, which we've already been practicing how to do, or at an endpoint. So honestly, we could probably draw 10 different graphs to help reinforce this, but notice this one quick picture I made. One of them, one of the relative extrema ended up being absolute extrema. One of the endpoints ended being the absolute extrema. So extreme value theorem really just says if you want to find the biggest and smallest points, you need to check all of the critical numbers and check the endpoints. It has to occur at one of those. We didn't need to worry about anything between any of them. Okay, so question one, find the absolute max value and absolute min value of this function between these values, and then remember to show your work. Okay, so what you need to see, or what's supposed to go through your head as we do these things, when you see absolute min or absolute max in your head, I hope that that sticks to extreme absolute value theorem. And extreme value theorem tells you your answers, your absolute min and max, are going to come from critical numbers and or endpoints. So those are the things we need to seek out. We still need to find critical numbers, just like last class. They are where the first derivative is 0 or undefined. x equals 0 is a critical number, x equals 2 is a critical number. So those are likely to be relative extrema, but just because they're relative extrema doesn't mean they're absolute extrema. This picture shows that. Here's a relative min. It was not, oh, well, here's a relative max, but it wasn't the absolute max. So even if one of these is a relative max, it doesn't mean it's the absolute max. Okay, and we need to consider endpoints. So it could be at x equals 0, x equals 2, or it could be at one of these two endpoints. So your work that you want to show, bless you, to show your work, we have this thing called a candidates test. And like I said, this is the part that I can promise you will be on your AP exam. And it's the easiest way to do your justification. They're going to want to see that you did a table where you test all of the critical numbers and you test both endpoints, because, and you don't have to refer to extreme value theorem, you don't have to know the name, but it's helpful if you know that this is extreme value theorem because it's the one that tells you what things to test. So I've got 4 x values and I need to know the corresponding y values. So should I plug these x values into the derivative? Good, because that would give me slope information. If I want to know y, x, y, that's a point. When you want to know a point, you need to be plugging into the function. So 0 minus 0 plus 1, 8 minus 12. Well, all of this is pretty easy to do without a calculator, but just for time purposes, let's cheat here. You plug 2 in, you get -3. You plug in -1/2. You get, I probably would have been quicker to do it by hand. My calculator was in the wrong mode. 0.125, and test the other endpoint when x is 4, y is 17. So this that I have boxed in red, this is the only justification you need for FRQs for these question types. If you don't want to do that and you want to justify it another way, I'm not saying it's impossible, but it's very unlikely, because you would need to say what numbers you tested, why you tested those, not others, what the difference is. But if you just test the critical numbers and the endpoints, this is what's called a candidates test. This is what they want for justification. Okay, and then if you do that, now the answer should be painfully obvious. These numbers should show the absolute max and absolute min. So what's the biggest value? Okay, so we got to be careful what it's asking for. If it is asking where is there an absolute max, it would be x equals 4, but it wants the absolute max value. So the biggest of these here is the absolute max. So I know that's the very highest this graph goes over the entire function, at least in this interval. And then which one of these is the smallest? So -3 is the absolute min. So again, if you graphed this function from here to here, this is as far down as it goes and this is as far up as it goes. These two just ended up not being the biggest or the smallest, but you always have to test critical numbers, you always have to test endpoints. That's all they come from. And that's all that extreme value theorem says. Okay, so question 2, looking at the graph of f prime, we can find relative extrema at the x-intercepts. Can you find the x-coordinate of the absolute max and absolute min? So first off, let's just talk about the stuff from last class. Again, be careful, this is a derivative graph, not a function graph. Where do you think there would be relative extrema? Okay, so is that a relative extrema? Okay, but it's at 0.
And it crosses over the x-axis.
All right, so when the first derivative changes from positive to negative or negative to positive. So x equals 1, x equals 3 are relative extrema. One's a relative max, one's a relative min. You're going to practice more of that today on those few book questions, so I'm not too worried about that today. But this question is wanting us to find the absolute. So it could be at x equals 1, this is as big or as small as it gets. And at x equals 3, it could be the big or as small as it gets. But what do y'all think? I'll let you think about it a second. I need to put attendance in anyway. Okay. Any guesses on whether we could do this? I think you can make some pretty good guesses at least. So remember, f prime is how f is changing. So I don't know what f is here, but since the derivative is positive after that, is f getting bigger or smaller? Bigger. If the first derivative is positive, your graph's going up. So my function is getting bigger, 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 bigger. Does it start going down here? Be careful. The first derivative is still positive, so he's slowing down, but he's still increasing. He's still going up. He's just going up at a slower rate. Still going up, still going up, still going up, still going up, still going up. So all of this kind of represents how much up the function is going. Likewise, once the first derivative is negative, we know the function is decreasing, so he starts getting smaller until he's back to here. And then what happens between 3 and 4? Does the function get bigger or smaller? Bigger. So if you kind of visualize that, so we don't know what the value is at the start, but we know it gets quite a bit bigger till 1, then it gets a little bit smaller from 1 to 3, and then it gets a little bit bigger from 3 to 4. Can you tell me where you think the absolute max would be? Where would it have grown the most? I agree, at x equals 1, because all of this is increasing from the start value. And sure, this is taking it away some, but x equals 1 would be where the absolute max is. That's where it's had the most growth. Okay, I think this one's probably a little bit harder, but what about absolute min?
X equals -3.
Perfect. X equals -3. Why didn't you say positive 3? Because isn't it going down here?
Because it's not as much as the up.
Very good. And not as much as this. This took it up a whole lot. This subtracted just a little bit. So it was actually the smallest wherever it started. So I don't know. I'll try to visualize this, I guess. I probably do a bad job. But so if we had some value at -3, we don't even care what it is. I'm just saying it's 1. And then it keeps getting bigger till x is 1. So at varying rates, but it increases the whole time. Then he decreases from 1 to 3 because the derivative is negative. So at varying rates, he's going down. And I know he's not going down as much as this one's going up because there's less area involved. And then it goes back up from 3 to 4. Well, that's misleading. It goes up from 3 to 4, but not very much. Little bit of area, little bit of up. So x equals 1 is where we said the max was. So you can see it had the longest to go up. And hopefully that visual here helps you kind of see why x equals -3 is the lowest. So kind of a different type of question, honestly. But we do more of this type of stuff second semester. We actually, just to give you something to look forward to, one of the things we do second semester is we can calculate how much area this is exactly under the curve, even if it doesn't fit a nice, neat geometry pattern. Okay, so let's look at just a couple of examples here. The first one I want us to just kind of walk through together as a group, and then I'll have you do question 2 for one guided practice question, and then we'll put this aside for the rest of class and we'll worry about the stuff we did last class. Okay, so if this says find the absolute extrema, the absolute max and absolute min, which theorem is that? Sorry?
Extreme value.
Okay, extreme value theorem. And extreme value theorem says your absolute max and mins will occur at where or where?
Endpoints or relative extreme.
Okay, check out the endpoints. Well, you should really don't say relative extrema, just say critical numbers. Critical numbers and endpoints. So they already gave us the endpoints, -2 and 5. Those might be the biggest and or smallest values, like the graph on the top of your page. I made one of the endpoints be an absolute extrema, but it could also be a critical number, which that picture at the top of your front page, I tried to make sure that you saw one of the critical numbers ended up being the absolute. It doesn't have to be the endpoints. So of course, if you've got to test the critical numbers, you've got to be able to find critical numbers, which is part of what you're going to practice more of in a minute. But critical numbers come when the derivative is 0 or undefined. So take the derivative. If there's an x in the denominator, solve to figure out where he's undefined. If it makes sense that he equals 0 somewhere, solve for that. Looks like this guy only has one critical number. So I know both the absolute max and the absolute min either occur at x equals -2, x equals 5, or x equals -1. How did we find these y values?
Plug it into the function.
Into the function. If you want points, this is important as we move along because we're going to start using second derivative next class. If you want a point, you plug it into the function. If you want to know the slope or the direction, you plug it into the derivative. And it's important that you keep those things up because sometimes we're going to plug numbers into the second derivative as well for something else. But that's for another day. So we get 1 plus, let's see, this would be -1 squared, which is 1, plus 1 is 2. Plug in 5, 6 squared is 36, plus 1 is 37. Plug in -1, you get 1 plus 0 squared, which is 1. And as long as you know what to test, your answers are right here. Here's the biggest value, absolute max, and here's the smallest value, absolute min. What you need to appreciate about extreme value theorem is it basically just took tons of stuff off your table. You had no idea what the biggest and smallest values of this are without trying to figure out what the graph looks like, which is its own amount of work. But when you know which numbers to test, it's actually pretty quick. Okay, I would like you to try this for question 2, please. And I would like you to try to do it without looking at question 1. See how much of it you can do without even looking at your notes. Obviously, if you get stuck, then glance over, but... Okay, is that long enough? Okay, so hopefully what goes through your head once you finish practicing this, again, you're not going to have to do more of this today. I just wanted to introduce you to it. The sooner you hear about it, the sooner it is that your brain catches on. But extreme max, extreme min is extreme value theorem. Extreme value theorem says you only need to test the endpoints, which would be given to you, and any critical numbers, which we need to be able to find for other problems anyway. Critical numbers are when the first derivative is 0 or undefined. So in this question, that would be 0 and -1. And both the absolute max and absolute min have to be in this list. You don't need to test anything else. That's what the value of extreme value theorem is. It narrows it down to 4 possibilities. Then just be careful that these are points, so you need to be plugging in not into the derivative. That tells you slope. If you need points, you're plugging into the function. So you plug in 0, you get 4. You plug in -1, you get 5. You plug in 1, you get 9. Okay, I'm doing this quickly, so 16, -12, and 0. Okay. All right, and then you can see this guy's the biggest, and the absolute max has to be in this list. So the absolute max is 9, and it occurs at x equals 1. Depending on what it's asking for, your answer could be 1 or 9. Be careful. Your absolute min has to be in this list, and I can see the smallest of those values is 0. So the absolute minimum, or the absolute minimum value, is 0, and it occurs at x equals -2. So just be careful. If it asks for the value, you want y. If it asks where, you would want to know the x. Okay, anything that jumps out at you about this topic before we move on? Okay, so again, we will practice the rest of this another time. So of course, if you finish the other stuff today and you're wanting to get a head start, you can do more of these. But next time you hear it, it'll be much more familiar to you, and it will go that much smoother. Okay, so from here, we probably need to break into 2 different groups. I am going to let you ask if there was a question or 2 at the end of assignment 40 that you had trouble with. Since we ran out of time last class on those, and I didn't have specific help for you on the website, that's why I'm offering that. The only reason I didn't ask you to turn this in today is so that I could give you a chance to ask questions, but I will ask you to turn this in next class, and I will even open it up in Google Classroom. So that's what I'm going to do next. But if you don't have questions, if you were good with the last few we didn't get to, you should move on to 41, which needs to be done on your own paper, please. And you can see it's super short. 6, 7. There's really 8 questions, but the 8th question has 4 parts. So that is the stuff that we did last class. This is the stuff I want you to practice more. Using the first derivative to find increasing, decreasing segments, knowing what a critical point is and how to find it, and if you know where it's increasing, decreasing, and you can make the sign chart, you should be able to do the first derivative test and name where the local or relative extrema are. So again, if you don't have questions from 40, we'll move on to 41. I'll leave that book assignment up for just a second, and I'll put it back up later as well. But you need to copy that down quickly if that's you, so I can answer the questions that people had. I'll put that back up. But question 3 and 5 are the first couple, so that's enough to get you going, I guess. Okay. From your homework last time, was there any of these that you struggled with or thought were harder? Yeah.
13.
Number 13. Let's give it a shot. Okay, what is the maximum value of this on the open interval negative pi to positive pi? It's interesting. Okay. So I know that relative extrema are going to occur at critical numbers. Not that all critical numbers are relative extrema, but all relative extrema are critical numbers. So we need to know what a critical number is. It is when the derivative is 0 or undefined. So take the first derivative, set it equal to 0, set his denominator equal to 0 if he has a denominator with x's in it, and then solve. So we could divide both sides by -2. And so the only critical numbers are going to occur where sign is 0. So that would be at 0, and pi. And so I guess that's the two things that I would try. What really is throwing me off here is I don't like how they're asking about maximum value, because we hadn't talked about extreme value theorem at that point. So really I should be testing these endpoints, and I should be testing the critical numbers, but I don't think that's what they intend to do. So let's see if we just try the critical numbers. So I make the little sign chart. I think x equals 0 is a critical number, and I think x equals pi is a critical number. So those are the only two places that might be changing direction. So I will try putting maybe 1 into the derivative. Okay, 1's kind of a weird value. I kind of want this to be in terms of pi, so I can do this with unit circle. I'll try pi over 2. -2 times the sine of pi over 2 would be -2 times 1, which is -2. Which again, I could care less that it's -2, just that it's negative. I could test a number. Oh, well, here's pi. Let me test. Do you remember what the answer was? Did you jot that
No,
down?
I just erased it.
Okay, let me look it up, because again, it's kind of throwing me off. I would just do extreme value theorem here, but I know that's not what they intend for you to do.
Wait, I think the answer was 0.
I mean, to me, that makes sense with my picture here. I just don't know about this interval. Since it's max value and I know it's going down, it's got to be at the highest point at x equals 0 between those two. But again, I'm just not crazy about that question. Oh, well, okay, I just fell into the trap that I tried to warn you about on the other questions. So it is at x equals 0 that there's a max, but 0 is not the answer. 0 is where the answer occurs. 0 is not the value. 0 is where the max value occurs. So I need to plug 0 in to the function. 2 times the cosine of 0, so the max value would be 2. That's what they did. But honestly, if I saw this on a test, I don't know. Again, I'm trying to work it in a way that I think made sense with just last lesson, but I would have tested, let's see how this goes, the endpoints and the critical numbers. Although pi is already on there, you don't need to do it twice.
So did you do what we just learned today?
That's what I would do, honestly. But again, that's why I didn't work it that way the first time, though, because we hadn't talked about that yet. But yeah, endpoints, critical numbers, some of that overlaps. You plug in pi, you get 2 times -1. Plug in negative pi, you get 2 times -1. So what we did this morning in those notes, to me, is more efficient because I'm not guessing what they're talking about. I tested the endpoints, I tested the critical numbers, I know the answer has to be there. Okay, what else you got from the homework? Yeah.
Did you do 16, like, all of it?
Okay, 16 says, well, there's a lot of stuff here. Let f be a twice differentiable function. That just means you can take its derivative more than once. Defined from -2.1 to +2.1. F of 1 has a value of -2. The graph of f prime is over here. So make sure you're aware this is not f, but f prime. F crosses the x-axis at -2 and +2 and has a horizontal tangent line at x equals -1. So right here, there's a slope and a first derivative. Oh, sorry, that's not a first derivative. The slope there is 0. And g is defined by e to the fx. So that's kind of weird, but let's see what happens with it. Okay, part A, write an equation for the tangent line. Okay, before I even read anything else, tangent lines are linear. The easiest way to write a linear equation is with point slope. They're giving you the x value so you know where to go. And then this is something that I've been harping on quite a bit today. Knowing the difference between plugging into the derivative versus plugging into the function. If you want a point, you need to plug into the function. When you plug 1 into the function, you get a value of -2. So when y1 is -2, that becomes a +1. But if you want to know the slope when x is 1, you need to get that from the derivative. So when the derivative is 1, at 1, the derivative is 3. So this is what they want for part 1. All right, you okay with that? Okay. Part B, find the average rate of change from -2 to 2. Okay, well, he's right here at -2. He's right there at 2. This is already rate of change because it's a derivative. So if he's at 0 at -2 and he's at 0 at +2, how much did he actually increase? He didn't. If you have $0 on this day and then you have $0 on this day, you didn't increase at all. You went up 0 over a distance of 4, but your average rate of change is 0. This is basically the slope formula. I know this value, take away this value over that much time. It has no, or on average, it has a slope of 0. Okay, for negative 2.1 to positive 2.1, find all the values where g has a local minimum. So notice they extend the graph just a little bit so that it crosses the x-axis at 2 places. So there's 2 times the first derivative is switching from negative to positive or positive to negative. If you want a local minimum, you want to know where the derivative is going from negative to positive. And that's happening right here. The derivative was negative and it becomes positive. The graph was going down and then the graph starts going up. So at x equals negative 2 would be where there's a local min. Still okay with that? Okay. And then the last one, it's pretty scary looking, but let's give it a shot. Second derivative is all of this mess. If I plug negative 1 into this, is it going to be positive, negative, or 0? So everywhere there's an x, we will plug in a negative 1. Okay, and okay, so some of this is going to be easier than finding the others. Right here is where f prime of negative 1 is. I don't know what that value is, but you see that it's something positive because it's above the x-axis. So I know this is positive. It wants me to say something about the second derivative of negative 1, but they only give me the graph of the first derivative. So how do I take information about the first derivative to know something about the second derivative? Would it be 0? This part's not 0, no. I don't know about the whole thing. I haven't made it that far. Okay, if you want to know something about the second derivative, one way to do that is to think about the... Oh, I'm sorry. You're right. I was just thinking about y. The slope of the first derivative is one way to have information about the second derivative. So the reason they told us this has a horizontal tangent line here is if the slope at negative 1 is 0, then the derivative of the derivative is 0. So if we take a positive number and add 0, I know all of that is positive. And then for this part, he is also positive. But, oh, yeah. Well, no, never mind. Okay, so there is enough information here, but it's a little bit of a stretch. So e to f of negative 1. You might be tempted to say that f of, oh, negative 1. Right, but how do you know, obviously this is positive, how do you know that this is positive?
Well, it shouldn't matter if it's positive, but if you take e to a negative number, then that's just going to be a positive fraction, so it's still going to be a positive number.
Oh, okay, yeah, that makes sense. Whether it's e to a positive number and is positive, or e to a negative number, that's the same thing as like 1 over e to the positive 2, which is also positive. You're correct, that makes sense. I was thinking, the way I had thought of it was, I know that at, never mind. I thought that they told us that this was a positive value to start off, and since I know it's increasing, I know it's still positive, is what I thought they were going for. But you're right. So if this has to be positive, and so you end up with a positive times a positive, which is why that crazy second derivative that they're making up would need to be positive also. That's a pretty wild question there, though. Okay, so quite a bit to that one. Does anyone have any follow-up to that last question 16 you want me to say again? Yeah.
How did you get slope of 3 for A?
How did I get a slope of 3? Well, if you want to know the slope at...
It's asking for G.
Oh. Whoops. Man, that would have been nice. Okay, I messed up part A because I didn't read it carefully enough. This was supposed to be the graph of G, and I was working with F. Okay, the good news is it's still a tangent line, so I still know it's going to be point slope. They do give me the X value, which is one of 3 things that I need. But to find the Y value, I don't need the Y value of F, I need the Y value of G, because they're asking me to do the graph of G. So if I plug in X equals 1 into G, it is e to the f of 1, and f of 1 is -2. They give me that in the problem. So e to the -2 is like 1 over e to the +2. Does that look better? Bless you. Okay, what about the derivative though? If g is e to the f of x, what is g prime going to be equal to?
Is it e to the f of x times f prime of x?
That is absolutely what it is. Derivative of e to something is e to something, but because of chain rule, you need to come back and multiply by this. So if we plug 1 into this, we would get, well, I already did this. This was 1 over e squared times f prime of 1, which is 3. So 3 over e squared. You know if that's what they got? Oh, okay. I'll check. Yeah. That's what they got. Thank you for catching that. Okay. Anything else you see about 16 you want me to clarify? Okay. Last chance. Anybody who's not asked a homework question have another? Okay. Anybody who did ask one have a second one? Okay. Give me 2 seconds. I want to open this up in Google Classroom before I forget. So as always, you guys are welcome to turn it in Google Classroom before next class, or just make sure you're ready to hand it to me at the start of next class, either one. Number 40. Sorry, I already had it open in Google Classroom.
Yeah, that's what I did. But, okay, so this is negative.
That's fixed.
You also did Jane. I missed Jane, that's why. I missed I still miss Jane. Yeah, that's really good. Okay, I'll go. I miss chain rolls. Back it up.
How does that become the negative for all? You take it away from the negative. One half. That brings it down to the bottom. Did you figure out?
Could I see what we just worked on? There's the 16.
You need to see question 16?
Yeah, because I did it like whenever before you saw that it was G.
Oh, my bad. Yeah. It's also on the website.
Oh yeah.
You just need to see part A or the whole thing?
I can just look on that.
Oh, okay. Okay, I'm gonna, now that that's opened up in Google Classroom, again, you guys are welcome to turn those things in there. You're also welcome to give me the hard copy as always, but we try to give you that option. But I will come around and try to help out with any of you. But again, this is not extreme value theorem. This is the stuff we did last class. I just want you to get a couple more practice problems under your belt.
I don't remember, I just.
Know what a critical number is, how to find it, know how to make a sign chart, figure out where things are increasing and decreasing. And once you know where things are increasing and decreasing, you should be able to say where the relative extrema are. You say that like you're surprised.
Well, sometimes it's bad. And usually the higher the numbers get, the worse it gets. But
Any book questions yet? So I apologize. I tried like 2 or 3 times to also attach the odd answers to the back like I've been doing, and I failed 2 or 3 times and got frustrated. But just so you guys know, there's still plenty of ways for you to check your answers. I do have every one of these questions except the last 2, because once you see 90 part 1 and part 2, students have never asked about part 3 or part 4. So I have them all worked out. So one thing you could do is you could pull up the video, skip to the end. If you got the same answer as me, then that must have meant you did it correctly. If you got a different answer than me, then maybe you should watch the video. But I also sometimes try to put this on there. Which you don't need to bookmark this website, but if you're on our class website, one of my links below this says Odd Solutions. And I've not pointed this out to you guys before, but these odd solutions, the ones that are provided by the textbook company, the nice thing is not only do they share you what the answer are, but they also try to show the steps. So I don't know if question 19 is one of your problems, but if you needed help with 19, you can change this. You can see the answer below, but you can also see what they got for a derivative, what they got for a critical number, and sometimes that helps you figure out where you went wrong. So you're also welcome to pull that up on your Chromebook while you work.
it's supposed to be one, cause if you take
Yeah, this is supposed to be one shot.
You were gone last time, so this might be a little hard for you now.
yeah, but if you
Did
take
you start catching your work up yet?
here, you take the derivative of
Oh,
the,
shit.
yes, yes, it's supposed to be one.
Okay,
So,
well,
did you
the
get-
questions might be
how
hard
did
for
you
you
get
at first. You might wanna do the
Is
notes
that
first.
your zero?
Yeah.
Yeah.
You got something I can help with?
Okay. Glad we figured that.
Okay, so you're gonna have to do product rule.
And it's,
Okay.
is this part, this
You're
part
on
check?
that. I need to do one of those.
Right?
That plus
And it simplifies them to X.
Cause I'm doing the square root of 32. Square root of
That looks right.
32. Square root of
And then I
32.
just don't know
it
how,
just gets messy.
yeah, and then when it gets to this part where it's,
Well, see, some of this you can cancel. You've got like, all of this is being multiplied together. So you've got a times 2 and a times 1/2, so those really cancel.
so when I have like negative 2x squared over square root of 16 minus x squared, I can do 2. I can cancel these out, and this is negative x squared.
Those are factors. This is 2 times of stuff, this is 2 times. So you can cancel out factors, but not terms.
X squared. And then do I have to add, do I just put it over 1 and then multiply it over the other, and this is minus x over 2? Like,
That sounds good too. Yeah.
so
So you're in the common denominator. The reason I'm saying that's a good idea is it's gonna make your derivative one big fraction.
Yeah, so, but like,
wait,
I've got
is actually, so it's negative,
oh,
16 minus x squared over 16 minus x squared.
But the nice thing is, well, 99% sure this is fine. If you can get your derivative to be a big fraction,
I'm not.
knowing where it equals 0, it's just where the numerator equals 0, and knowing where it's undefined, it's just where the denominator is.
And I set these two versus these two equal together, right?
You can set this equals to
My
0.
mom will take that threat too.
So this is that would give you all
I don't know, I'm gonna solve it. I'm gonna solve it the way I'm doing it, and then I'm gonna check the answer. And then always do that. I don't really understand it.
Sketch the graph of his derivative.
I don't know how they got from.
That's a function.
There are still
The x is equal to 0. So the fact that this is decreasing means the derivative is
You know,
negative, and then when it's increasing, the derivative is.
yeah, they're related.
So you just need to make a graph that's negative below the x-axis until you get to 2, and then above that. So it'll be linear.
Definitely.
Okay. And that should make
I don't
sense.
like it.
It looks like
I might be able to get it done.
Powered by 1. Yeah, so it's going from like a quadratic to a linear. It's decreasing to
Why did we do analytically C?
Oh, that's the, 5 proved that to me.
Oh, does it fall more?
So,
Or like, if like a graph shows it, yeah. Then like, you can't correct the graph.
but
Oh, the graph is just wrong.
The graph is wrong. What's crazy?
Or this is right.
If it's negative, it's gonna be.
and then
So what did you do?
actually stop by the price of 2 by the and I was like, hey, it'd be no. Yeah, I'll fix the one and then add there's another sign and also the 0. Which I also
Quotient. Because it's
from like negative 3
negative quotient.
I changed it to 3/4 times x.
It goes through.
That's not on the fraction. Like, there's a. I swear my. Yeah.
You did that. 70.
I bet it was you.
71.
Or feel like once a year.
I thought I was the biggest
Okay,
fan.
that wasn't necessary. I don't know why you did that.
Okay.
I think it was all the. I think you actually
I don't know why anyone would hate him.
She killed him.
I know that I did that.
It's probably like Brendan
I'm trying to warm my face up. My nose is frozen.
Oh, it needs to be what?
My mouth?
I got
I can't warm
Oh
up.
my gosh, I thought it was your mouth.
How do you even?
So,
My hands on my face.
if
But I
you let
can
in
hear
your
all
natural
that.
light, it would be
It's not shining this way.
It reflects.
Oh.
How do you know you're north, south, east, and west?
It reflects. The light reflects. Let me show you. That's why we can see stuff.
Oh yeah, I wrote that.
No, I'm just.
But the sun doesn't rise from north to south, which is what was.
So I'm thinking it's negative up until
Maybe not like the wires, just the direction.
increasing to 0, 0,
What planet?
6 is larger.
You should
than
get a
not-
spatial.
That's what.
As long as you bring her fire pit.
6 is
Yeah,
larger.
I'll bring my
I was
spatial.
trying to find something larger because I'm doing intervals.
Is that the open flame?
And then
It's not.
add two.
I have one of those, it's like electric. I don't, you got one of those solo stoves that like you can turn on.
Is it an open flame? Oh, that won't show that.
I forgot that it could curve.
We can't even have cameras.
No candles.
We might set the building.
Well, I
No,
can tell
seriously,
you,
they don't trust us.
I've left that social meter on for a whole night. And my house is burned down. Kids, period.
Maybe she just needs to set out deodorant or something.
I say go against the policy, just let it fire.
Okay, I can do that for a few days, but we have fire marshals come and check, and they write stuff.
that looks stupid, but it really, because it can go down.
Notice like
Some
a
stuff
shard.
has to be plugged into the, like, my refrigerator has to be plugged in straight to the wall, not as a, no extension cords.
Alright, so
There's
just.
lots of,
Alright.
I bet she does now, I bet she does.
It's increasing
Also failing it.
It's negative what?
I mean, it's
Failing it.
This is
negative.
the,
One of my friends are, and then
it's a different-
negative 2.
What our smart friends are like having
Yeah.
sessions in that class.
So the actual graph.
So I went down.
Institution.
Sarah and I had
I'm just saying it's positive.
Did they have pre-cal already, or is it their first?
Even if it's going down, the slope's negative.
That's
It's
zero.
their first AP math, and it's their first experience with pre-cal.
But it's also a brand.
I'm sure they would have much lower grade
Would have done
population.
better if we had I promise you they did.
Instead of calculus.
Still like that, if you took
And odd.
Wait, what?
I don't think so.
It's
We've set pre-cal
from
up
negative
for
infinity
us.
to negative 2. And it
The
is what
idea
the
of
graph looks
pre-calculus
like.
is to set you up for calculus. So all the algebra practice you did, all the, most of the tricks that you learned, is stuff that shows up at some point in this class. We've kind of cut out the stuff that doesn't show up at school. AP pre-cal, they have to do like matrices and conics, and
That's weird.
that's good stuff to know, but it doesn't help you.
Like the flip.
I did have
It's very different.
I bet
I have no idea.
I mean, we could write the equation. I just for this one in particular, we
But-
could write it.
But the other ones.
We were told what to teach in each class. We have state standards, so we can't just,
But we would never know what
the point of those classes is not to help the day.
So, even though I'm I wish my ninth grade self was for geometry.
I'm
I know, but like,
I think I would enjoy geometry a lot more.
I think they just made it. It's not on the paper.
It's still or like, no, like actually like bend over and touch her toes. I don't think she can do that. Yes.
I swear, it's wrong. It's actually wrong.
Are you doing this one?
Yeah.
Okay, so critical numbers are where the first derivative is 0 or undefined.
I'm a very aggressive eraser. I'm sorry. Like,
Well, what are you
pretending like I did this one right.
Oh, no, that's right. We don't have to.
But at 1, can't you see the derivative is negative?
I'm pretending like I did this one.
It's below the x-axis. And at 3, the derivative is positive because it's above. So if it was a half, so it's a minimum. The slope was negative, then the slope was positive. Relative to minimum. You don't remember doing a few of those in your notes from the graph? You're just thinking about where the derivative is positive or negative. If it's switching from positive to negative, it's relative max. If it's switching from negative to positive, it's.
I was just thinking we have to make
It's important because the parents are
Is it relative to us?
I know, be it 0.
Wait, no.
Anything jumping out at you? Do you want me to help verify real quick? Okay.
simplify out the one that has
Okay, so this is the first derivative. So critical numbers occur when the first derivative is 0 or undefined. So when is a fraction equal to 0?
You can simplify out the one half.
Okay, so they said 4x equal to 0 and solve, and that's how they got 0 as the critical number. And then when is a fraction undefined? Right, so then they said the bottom equal to 0 and solve. And then you can divide both sides by 3, but 0 divided by 3 is still 0. You can cube both sides, but 0 cubed is 3. Add the 4 over, take the square root of both sides, and when you take the square root of both sides, you need plus or minus. They figured out where this is. They just said 4x equals to 0 and solve that equation. And then they said this equals to 0 and solve that equation. And that's all the critical numbers. And critical numbers are the only place that might be changing direction. It could be changing direction at -2 to 0. You have to test once in a while. You plug in random points. Anywhere the derivative is positive, you have the graph line up. Anywhere the derivative is forward. If you know where it's going up and down, you can figure out where you know it's going down and then up. You must have had a relative. And I don't mind if you use their notes, which is why you know where to find our class reports too, right? Okay. Okay, does anybody have a book question I can come over and help with? If you're trying to finish without homework, you got about 20 minutes.
I keep thinking it's like,
Okay, but like, I mean.
that's for,
Why did
and then the max would be.
I'm gonna look over.
a 0.
Yes.
I pray for you.
He always wears. Do those actually work? Oh, there's that one guy who like lost all his hair. Like the reuse stuff. Yeah, it's like a little thing. Yeah. So this one. You know. 3.
Yeah.
Negative 3. 1.
No, not 1, because it doesn't.
I thought it was a different 0.
No, but it's only, the critical number is only where there might be a change. Right.
I thought when we were like A equals 0.
And you're all the way on 97 already.
Because if it's always positive, like 0 just means stop it. Not necessarily switching back over.
Yeah, so negative 3.
Okay, it's like a rotating step.
Because it should be 3, 2, 3.
Decreasing
So
to
it
negative
increases and then skip 1.
Okay, 2 quick announcements. Everybody did great this time about making up the tests. So the third test has already been completed by everybody. So that means that you're welcome to come see yours anytime during advisory. So if you want to sign up next week on Tuesday, I guess that would be the earliest since you can't sign up this late in the week for this week. But you're welcome to come see your third period, Unit 3 exam, and of course I can help you with that stuff. And if you're interested, I know you guys thought that there was or at least one of my classes thought there would be a big curve, but overall I was very happy with it. Second period, I don't know, but y'all still, y'all had almost. Actually, you ended up having the highest score after the curve. How do you think that you had a lower score before the curve but a higher score after the curve? I think it means fourth period must have had more people make 100 and the curve didn't do anything to their grade, so. But whatever. Anyway, if y'all have any friends in second period, please tutor them. 'Cause I don't know why theirs is so much lower, but anyway, that's where we're at.
Negative 3 is.
But it wouldn't be the one, right? It doesn't go true. And then, yeah.
You can also come and see your first test, the one on limits, and you can come see your second test.
You'll probably get where we were doing derivatives, by the way.
Both of them online? I have two of the same one.
So you see what you got in it yet? Yeah, like 75. Yeah, that curve saved you.
I said negative 3.
I'll probably get like.
I definitely like
I didn't consider
I had to go with one right or something. I had to go like one right or something because I know there's like one question that you and I couldn't do that. Dude, there was the very last one, the triangle one. I knew exactly how to do it. For some reason, I couldn't figure out the square root
Oh, you just had to know your Pythagorean.
Yeah, I
The
just
7, 24, 25.
I spent the whole time trying to find out the square root.
I got that one. So I remember
I have no idea. I was literally rewriting like 30 times.
I did topic. Various different methods.
That's where.
Oh, then that probably makes sense. No, it's a function, so it can't stop anyone. So that it can be
What if I were to try to and then if he did, it'll like jump behind me. And like he's trying to be smart and do it other ways. And I get it wrong. We get the
So it's just like that, yeah. But like my
I keep working it different ways and I get different
oh yeah, I didn't read that.
you don't know who's
Like
going on.
increasing is like decreasing, so just we're just putting into would you take the one yeah, so like you find the I started with a relatively like back 6 minutes or whatever, and then you're like
I love it.
it might
be a different.
Do you keep the one
I have two.
No, I
Or it might be the other one.
Okay, I've got their numerator, but I don't know how that was not. I was getting it, and then I did it, and I looked over, and I was off by 4. So that's the original.
Don't look at the picture yet. We can confirm.
Wait, so was I answering all these wrong?
Oh, I go across.
Technically, yes, but you did all the work. So question 5, I think when you did this,
Oh, that's one.
this should be wrong. You should say
So we're not even trying to find it.
Oh, it's a plus.
right, yeah. You're going.
I was confused.
Never mind. I got it. Otherwise, I'll have my dad today for
Oh, but then the point of the graph, like when you did this, it's all the answer. I looked at the graph. Increasing every shot, decreasing when you talk. So the first two they did just make sure they
Okay.
yeah.
Okay, I'm going to switch the screen here. We've got about 8-9 minutes. So, I will take up assignment 40. So if you happen to not have it complete, come into class today. You can still finish it and still get full credit because I just didn't take it up today. I will also take up assignment 41. You are welcome to turn both of those into Google Classroom, but otherwise I will need the hard copy next time I see you, which will be Monday because there is no school on Friday. Okay, I know you said this. Okay, for our daily puzzle, have y'all done the eye test puzzle?
No.
Okay. Alright, if you would rather participate on the puzzle, that's fine. Just make sure you know what your homework's going to be. Well, it's an ad.
The attraction towards new experiences is powerful.
Hello, hello everyone. Welcome at Brain Games. Are you ready to test your eye?
Let me try again.
New game? This game is simple. They all look the same. One is different. Can you test your eyes?
Okay, so you try to figure out which one's a different color.
Which color blue is different?
Oh, I'm sorry.
Did you have the first question right? Let's turn to yellow. Wow, this one is actually difficult. Let's continue testing those eyes. 1, 2, 3, 5, 6, 7, 8, or 9. Which one is different? If you like the quiz, hit the subscribe button so we can grow together.
It will get harder.
I see green. Ah, wait. One is a little bit darker. Question 6. This one is easy to boost your score. None of these you guys ask. My favorite color, orange, the color of the Netherlands. Which one is different? Tonight, keep going everyone. You got to keep an eye on the timer. We made it to question 10. Yep. I guess my eyes are good. I found this one. Some are not easy if you ask me. Question 12, let's circle back to a little bit of the yellow tone. Loop for like, let's say 5 seconds. I finally found it. Whoa. You can find this one. Legend. Question 15, let's keep going. I think this is a fun game to play with your friends as well, by the way. 16, boost your score. Very easy.
Oh,
17, a little bit of an easy one as well, if you ask us. Let's keep going, everyone. Hit the subscribe button, like our quiz. Question 19, we made it to the halfway point of the quiz. Let's keep going. Comment your score once you finish below. This one is easy. I see light blue. No, I don't see this one. Wow, we're going into white. Let me see.